Thank you. Helping you make the world more sustainable means we need to run a sustainable business, which means constant reinvestment in research and development. Now, we at Esri often say that we spend 30% of our annual revenues on R&D, but stop and think for a minute about what that means. That's revenue, not profit. That is hundreds of millions of dollars that we spend every year enhancing the capability to directly support the work that you do. We've seen throughout today that demand for location intelligence, for our technology and for your skills has grown far beyond the traditional GIS world. We're seeing geography and GIS becoming an index onto the world, an index onto the systems and the data that run the world. I'm going to look at what Esri are going to be working on over the next 12 months, both in terms of detail of releases and also a couple of trends that are starting to shape our industry. Well, you won't be surprised to hear that we're going to continue advancing the capability of ArcGIS. And the reason that we're able to help you succeed in your roles is this continual capability of advancement. We want ArcGIS to continue to be a comprehensive spatial analysis system for GI professionals, for data scientists, for developers, and for wider society. Now, the third bullet on here is something we've only been talking about more recently. You increasingly expect to have that GI capability available on a world-class enterprise platform, one that integrates with your organization's systems and policies. Now, ArcGIS already is a world-class enterprise-grade platform. We've been working towards any device, anytime, anywhere for several years. But we believe we can do more in areas like DevOps, cloud deployment patterns, and other areas. So we'll continue to invest in our geospatial technology and work with our partners like AWS and Microsoft and make use of the best technology in the marketplace, such as enhancing our Kubernetes deployment option for even better one-click upgrades and seamless auto-scaling. As well as quarterly releases of ArcGIS Online, in July this year, we're releasing ArcGIS Enterprise 11 and ArcGIS Pro 3. Now, for Enterprise, this is the first major version number change for over a decade, so it's important to understand what that means. The versions of .NET we use internally are changing, which affects some SDKs. And from Pro 3, there is some system and configuration you won't be able to open in older versions. And from Enterprise 11, you will no longer be able to use ArcMap to publish services. Now, we are not making these changes lightly, but we understand that sometimes, in order to advance the capability, it is necessary to replace older products and services. So with these releases, we're making great advances in all areas of ArcGIS. For example, in big data, you will soon be able to embed ArcGIS directly within your own Spark environment, such as Amazon EMR or Databricks. What does that mean? Well, that is years of Esri's core geospatial knowledge and algorithms available for use directly by data scientists and business intelligence teams, scalable to hundreds or even thousands of cores. Previously, you had to come to our platform. Now we're taking our know-how to the platform that data scientists are already using. Unless we're able to work on terms that they're familiar with, then, to be blunt, the world's problems are going to be solved more slowly. Now, ArcGIS Geoanalytics Engine, as it's called, is released in June this year. Another big area for investment for us is integration and services, which is particularly important when you think about that model of geography being an index onto the systems that run the world. From Enterprise 11, we're introducing a new high-performance feature service cache, and we're also extending our support for OGC, the OGC API standards, to maximize interoperability. Now, what about VR and AR? Well, for augmented reality, the runtime SDKs already include great capability, which our partners are using today to develop AR applications. For VR, we're putting our effort, virtual reality, we're putting our efforts into the game engine SDKs, which Mark talked about this morning. And we've already been demonstrating these at game engine conferences, showing how our geospatial technology can turn them into immersive business applications. And finally, I'm sure you'll be excited to know that there's a lot in store in the future for ArcGIS for Microsoft 365, as we consolidate our existing products into a single offering that has components for Excel, for SharePoint, for Teams, Power BI, Power Apps, and probably some others as well. So when I look across this word cloud, which is a real list of just some of the R&D teams that Esri has working today, I am tremendously excited about the next 12 months. Our work is going to help you do your work better and integrate a geographic approach into the problems that your organizations are solving. So, what other trends are we seeing in our industry? Well, we've talked a lot today about how GIS is being used to make the world more sustainable. But one of the things that we're starting to see is a real focus on the sustainability of the GIS itself, of the infrastructure it's running on, of the resources it's using, and of the emissions resulting from that. Now, most studies suggest that today ICT, that's information and communications technology, contributes about 2 or 3% of global greenhouse gas emissions. By comparison, all the emissions from the UK amount to about 1%. And when we talk about this subject, it's important to understand, although I had a picture of a data center here, that data centers actually only contribute about a third of this. These numbers are hotly debated, I should say. So where are we starting to see this focus on the sustainability of IT? Well, this is an example from the UK Cabinet Office, from the Digital Data and Technology Playbook that was just published a couple of months ago. Organizations should undertake benchmarking of cost, schedule, greenhouse gas emissions, and outcomes at each stage of business case development. This is going to take a real change in mindset for IT and GI professionals to focus on greenhouse gas emissions in the commissioning and in the delivery of a project. Here's another example from the W3C Technical Architecture Group. We will consider power consumption and the resulting emissions when we introduce new technologies to the web. The only thing I don't like about this slide, by the way, is the focus on data storage here. So data storage is comparatively cheap in carbon terms compared to processing and compared to transmission. So what does this mean for us in the GIS world? Well, I'm going to try and do a little demo to show you. This is ArcGIS Experience Builder, showing Ordnance Survey master map of the centre of Bristol. This is not a base map, these are individual polygons being drawn. I should say, this building in the middle, by the way, if you don't know it, is called Cannon's House. So called, I believe, because if you swizzle it up that way, it looks a little bit like a cannon. That's the first time I've ever used the swizzle map functionality. Now, I often tell people that ArcGIS, by default, is a real-time system. So every time I pan the map here, ArcGIS will dutifully go off to ArcGIS Online servers in the cloud, retrieve the data and serialize it, which uses server processing resources, and send it back to me, which uses networking resources. And I get pretty good performance. But what happens if I zoom out a couple of times? Oh, the map's slow, but it eventually gets there. Now, I still think this is quite a beautiful looking map, but it's not a very efficient map, and it's probably not a very useful map either. There are about 50,000 polygons on this screen. So does anyone want to shout out what I should have done to stop so many polygons being drawn at this scale?
Scale thresholds.
Scale thresholds, good answer, or maybe generalization, that's right. And this is a really important point, directly relevant to that advice from the Cabinet Office, which I put up earlier. Your map design can have a very real difference to the greenhouse gas emissions from your GI project. Now, Esri are putting a lot of work into this area as well in developing our technology. So watch what happens if I zoom in really, really quickly here. I don't know whether you saw that or not, because it happened really fast. But ArcGIS, the building outlines resolved to a much more accurate representation as I zoomed in. And the reason for that is ArcGIS is actually generalizing your data on the fly where it can in order to reduce this network processing resources of getting it down to me. And the side effect of that is better performance. Let's go back to the lectern. So it's clear the sustainability of IT itself is going to become increasingly important. You and we will incorporate this thinking into our work, and you can expect more from Esri to help you do this. The other trend I wanted to talk to you today about is accessibility. I already talked about any device, anytime, anywhere. We really need to add anyone to this, whether those people have visual deficiencies, motor impairments, or other difficulties using ICT. This is the same app I just showed, and I've just run it through a common accessibility testing tool. And the very fact that this app passed the test with no errors is a very basic indicator of how important Esri see this topic. We at Esri now have a dedicated team responsible for accessibility across the whole of ArcGIS. But just as I talked about with emissions, we need your help here. You need to think about accessibility in your map design, the symbology you use, the color palettes you use. And you can expect more from Esri to help you here. So for example, in ArcGIS Pro 3, we are introducing, and later in online this year, we're introducing a color vision deficiency filter, which will allow you to see how your map looks to people with different degrees of color blindness. That's enough from me. I've talked about three things. Number one, how we continue to advance the capability of ArcGIS. Number two, how you and we will increasingly think about the sustainability of the GIS itself. And three, how important it is that anyone can use ArcGIS. You can see that we continue to advance our software and invest in the whole geospatial industry to support your work and the work that your organizations do. Now I'm going to hand over to Richard, who's finally arrived in the other Richard's Tesla, and first to Claire, who's going to look a little bit more at that idea of GIS as an index onto the world. Claire.
Thanks, Adam. Perfect. So we've just seen what ArcGIS has in store for us in the next year. But before we think about what we might expect from the GIS of the future, let's first take a few moments to think about what the GIS of the future means to us as individuals. For some of us, that might be about automation. For others, it might be making GIS more easily accessible or enabling better collaboration. Maybe it's integrating GIS with industry systems to help us tackle current and future challenges that we face. This integration of GIS and industry systems is what we'd like to focus on today. And it's much more than just bringing data sets together into a single system. It's the ability to make decisions and, most importantly, predictions that can allow us to better protect our communities now and to help us to build the communities of the future. So for the next 10 minutes, Richard and I will demonstrate the integration of industry systems within the context of recent events in the UK and across the world that have shown us that extreme weather is increasing in frequency and severity, sounding the alarm on the climate crisis. The systems we have today for monitoring our environment are vital for planning now and in the future. Thanks to the Met Office, we can visualise high winds sweeping across the UK from a recent storm, bringing with it heavy rainfall and potential thunderstorms. This regional weather data allows us to communicate flood warnings and weather warnings that enable us to make better decisions on protecting ourselves, our homes, and alerting us to the direct impacts of the climate emergency. But these workflows are already well established, so what role does the GIS of the future have here? Let's find out together by focusing in further to an area of Canary Wharf here in London. And we'll use this area of interest in the context of an incoming storm bringing extreme high winds. We're now looking at a detailed wind analysis for this block in Canary Wharf using Airflow Analyst. This is primarily a mixed business and residential area. And one of the reasons we're able to generate these hyper-localized analysis of wind is thanks to the ease of access to highly detailed building models, terrain, and other data sets such as trees and other obstructions that characterize our built environment. Bringing together these physical characteristics with wind direction and speed, we can determine that the wind direction in this area isn't as uniform as we might have expected. If we remove some of these data layers, we can start to see how the behavior of the wind changes at different heights as it deflects and moves around the buildings here. And moving now to ground level, this red band in the center here has been consistent throughout. So let's take a closer look at the wind behavior in this area. With this data, we can start to see what physical characteristics are both creating obstacles for the prevailing winds and are in the direct path of extreme high winds. A strong wind pattern moves around the back of this building, passing over a building site symbolized in the hatched area on the left, and continues throughout these streets. So now in our system, we've integrated local wind analysis data and the physical characteristics of this area in Canary Wharf into a digital twin, giving us rich information about localized wind patterns. So let's now take a look at the building site. So here on our building site, the site manager has been keeping up with local news and has ensured that the site is hardened from the reported prevailing winds. Thanks to the speed and ease of drone-based data capture, daily models of this site are captured as part of routine and maintenance progress checks. And these scans are detailed enough to be visually inspected. So here we can see we have some construction materials, areas of groundworks, and earthworks, and some loose construction materials here on the edge of the site. So whilst it is possible to visually inspect these scans, the site conditions or manifest is more easily tracked using machine learning. For example, using object detection, what would have been a manual stock take becomes an automated site manifest, capable of reporting the counts of material units and areas of current earthworks. And if we look a little more closely at the object detection results, we can see that this site has some units of loose construction materials here in the path of the storm. Should these materials be picked up by the high winds, they could cause damage to buildings, assets, or could hurt pedestrians. Integrating data reported from our building site into our system, we can begin to build up a picture of how this storm is likely to impact this area of Canary Wharf, using detailed local wind analysis and key information from our building site. So now it's over to Richard to take a look at the impact of this localized wind pattern.
That's great. Thank you, Claire. So Claire's just shown us how we can take regional storm predictions and then use them to get an idea of weather patterns at a hyper-local level. Now it's time to see what needs our attention and how we can help to mitigate the risks that are posed by the storm. So let's start by bringing back that wind analysis. Here we can see that these two buildings in front of us are at risk from flying debris from that construction site. Now, in this case, these two buildings are offices, so we can work with the building managers to issue a work from home directive and then work to secure the fronts of the buildings. But because our analysis is so detailed, we can also see that the rear entrance to the office is much more sheltered than the front. So essential staff could still make it into the office safely if necessary. Now, there's no doubt that this level of detail will help us to keep people safe. And it's only possible because our GIS is giving us the context of so many different data sets in one place. But our two offices aren't the only assets in the path of this strong wind. If we head round the corner here, we can see that there's also an electricity substation at risk. Now, our power networks are essential to keeping people safe, and we need to prevent outages as far as possible. A substation outage in this area could have a really significant impact on the power supply, but it's essential to quantify this impact in order to prepare the best response. So let's bring in our utility network data and see what the situation is on the ground. We can perform a network trace, which means that we isolate this substation and then trace back to see which buildings would be impacted if it were to go down. And as you can see, in this case, the impact is large, and it covers several high-rise buildings in the area. So now that we understand the challenge in a little bit more detail, we need to get some engineers on site as soon as possible to help fix this. This AI-driven worker allocation tool knows where all of our staff are in real time. It knows the skills that each of them have, the equipment they currently have on their vehicle, and how to match all of this up to the job that needs to be done, in this case, repairing that substation. It can then reprioritize a backlog of work and notify the most appropriate worker. Again, because this lives within this rich digital twin, we can derive the best course of action based not only on the utility outage, but also on the need to keep our workers safe and effective during the storm. In spite of this, you can see that the job completion time is still estimated to be over 2 hours away, and we simply can't have our network down for that long, so we need to do more. Naturally, our primary objective is to restore the network to full capacity. But at the same time, the network has attempted to self-heal itself by rerouting power from a different substation. It's worked, but it's left us with around 80% of our typical capacity. So now our job has become to reduce the power demand in this area in such a way that no vital services are lost. All of the buildings in this area are equipped with IoT sensors and other smart features, and we can use these to start to address this now. So we already know that our two offices from earlier are all but unoccupied today, but they're not the only buildings with reduced occupancy. If we have a look at the load sensors in this residential building, we can see that some of the apartments are only partially occupied, whilst others are completely empty. This is important information, and if we pair it with the fact that the modeling of our utility network continues inside the building, we can start to dynamically control this building based on that real-time information. Now, that's great on this individual building level. It's going to help us figure out what our minimum power needs are and then ramp down to them. But with a whole network of buildings set up in the same way, we can do so much more. The buildings can communicate with each other to agree on a collective power draw and then progressively ramp down to it. So some buildings might choose to power down elevators, others might power down air conditioning in unoccupied areas, and our office's fleet of company electric vehicles can even draw power back out of the batteries to supplement the grid's power. Between all of this, we can automatically reach a state of balance, where we're working to the grid's current capacity while we wait for a more permanent fix. Everybody remains safe with the services they need, and many people won't even notice that an outage has occurred at all. So we've just seen how the future of GIS can help us better prepare for extreme weather events. But our changing climate will bring with it so many more challenges than just this. In order to meet these challenges, we need to work together as one and bring with us the world's best technology, data, and thinking. And we believe that GIS is essential to this kind of global scale of collaboration. We've seen throughout today how ArcGIS is becoming ever more tightly integrated with the systems that run our world. and how it brings them together through the power of geography to make them so much more than the sum of their parts. But we've also seen how ArcGIS is becoming more accessible to more people every day, whether it's using complex deep learning with just a few clicks, or performing reality capture and then storing the whole results in the cloud with just consumer hardware. But you know, the best thing about the future is that it starts now. So we hope that today has inspired you to head back to your place of work, be ever more creative and innovative in the work that you all do. Thank you.